Okay, so this is finally working. Thank you. All right, so last time we left off with linear approximation, and we had this problem I left you with. So I asked you to actually work on this. Did anyone actually work on this? Did anyone actually do what I said? Yeah? Cool. All right, cool. Thank you. It's good practice. Let me just extend the chat so I can see it. Okay. So let's get started. So we have this position function for a particle, and I want to use linear approximation to estimate the particle's change in position between t equals 81 and t equals 83. Okay. So first, before I start asking anything, so what is the exact change? If I ask for an expression, what is the exact change? The exact change in the position is what? Can someone give us an expression for that? I don't want a number. Again, I don't want a number. I mean a symbolic expression that would give you the exact change in position. Good. What Thomas just put in the chat is correct. X of 83 minus X of 81. Okay. So now can someone, is this 4.6? Yes, this is 4.6. So can someone kind of now explain very briefly, or just kind of it's called sketch to us a solution for the rest of this? Like, what are we actually going to do now that we realize what quantity we're trying to approximate? How do we go? Where do we go from here? And you just told me a whole bunch of you worked on this. I know Jacqueline did this. Simran, I know, did this. P prime of 81 times 83 minus 1. I think you mean X prime of 81, right? Not P prime of 81. But so what Jacqueline is essentially saying, so we are actually going to use a linear approximation essentially to, really what's happening is we're going to approximate X of 83 using a linear approximation. But when we do the minus X of 81, it kind of cancels out of the equation, right? So, and how do we use a linear approximation? We use a tangent line, right? We use a tangent line to a nearby point. So we're going to use 81 as my point of tangency. That makes sense because the 3/4 power, I can do 81 to the 3/4 power. Okay. So let's get the tangent line. Okay. So we use the tangent line at t equals 81. Okay, so my point is 81, and I would normally need this for, say, another problem, but for this, I don't really need the X of 81. I don't need the Y value. I don't really need the point of my tangent line because, again, because I'm going to be subtracting it later, it's going to cancel out, so I don't really care. Okay, what is my slope? So that will be X prime of 81. So what is my derivative? So my derivative here is, so let's see, so the 3/4, that's 3/4 of 8. So that's 6t to the negative 1/4 minus 5, evaluated at t equals 81. Right, and what do we actually get for this? So let's see. We get 6 times, and t to the negative 1/4, right? What is 81 to the negative 1/4? Let me make sure people can actually do this arithmetic. What is 81 to the negative 1/4? Yeah, 1/3. Okay, good. So we get 6 times 1/3, that's 2. So we get 2 minus 5, so we get negative 3 here. Cool. And the equation of my tangent line is thus: y equals X of 81 minus 3 times t minus 81. Okay, and now we use this to approximate our difference. All right. So I kept writing this last time. I'm not going to write it this time because we should all be kind of experts at it now, but the idea is that this tangent line, what is the idea of this tangent line? This tangent line approximates the original function near the point of tangency. So I can say something like this. I can say x of 83 minus x of 81 is approximately equal to what? I can say it's approximately equal to x of 81 minus 3 times 83 minus 81, and then minus x of 81, right? What have I done here? The x of 83 I've replaced with the tangent line expression, right? The original y value, x of 83, replace with the tangent line approximation, right? That's the idea of linear approximation. And so what do we get here? We just get -6. All right, x of 81's cancel out, and I end up with -6 for the rest. All right, any questions? Margaret, any questions? No, okay. All right, so that's good. Miriam, I like your background. You know, one of the most popular mashups now is Bohemian Rhapsody. I can't play it in class because it actually is it is vulgar. It does use the original lyrics of WAP, but it is a very good mashup, Bohemian Rhapsody. So I suggest that everyone kind of look that up.
I have a question.
Yes.
So you found the derivative of AT to the 3/4 power.
Yes.
Okay. I just wanted
That's 6 times t to the
Yeah.
-1/4. That's right.
Okay, so you just found the derivative of the function.
Yes, because that remember that the slope of the tangent line is given by the derivative of the function.
Okay.
Yes. Okay, so let's